Welcome back to part 2 of parts of an atom. What we're trying to figure out here is the key parts of the atom, what are the different particles within it, and also where can I find them on the periodic table. And so this second essential question here is really focusing on that, the periodic table and how we get that information, knowing an element's period and an element's group. So here we go. The periodic table of elements, again, I know you've seen this diagram before, but what we're seeing here is a lot of information about each element as well as things about the specific atom of that element. So we're getting a lot of information like how many particles there are, so how many protons, neutrons, electrons, how many energy levels that atom has, what the mass is of all the particles within the element and the atom, as well as certain characteristics about the element itself, like what it looks like, what elements it might react with, different properties about it. So when we look at this diagram, it looks pretty basic. We can tell there's a lot of information, and so that's what we're going to start picking apart. So first let's think about what is going on in each element square, and that's what we call this. So the periodic table is made up of all the different squares of elements, and within this square is information all about one atom of that kind of element. And so here we just are looking at an example of a sodium atom, and there's 4 key things that we're going to look at on the periodic table. There's a lot more information, but for our purposes we're going to keep it to these basic 4. So the first thing I just want to point out here is we have the element name. And so that's written in full that we can see. And then we also have the element symbol. And sometimes the element symbol is easy to recognize. For example, like hydrogen is simply an H. Sodium here, Na, seems a little bit off. A lot of times it has to do with its official chem name or Latin name. So part of the element square is the naming system. The other thing on the element square are these 2 numbers, and each number gives us, again, specific details about that element. So the first thing I want to recognize is that the 2 numbers, while different in value, are also different in how they look. One is a whole number, while one is a decimal, and that's really going to help us differentiate between the 2 or tell the 2 apart. So we're going to start here with the whole number. The whole number is known as the atomic number. And the atomic number tells directly about the atom how many protons there are in the atom. So it tells me how many of those little tiny positive particles are inside the nucleus. The other number, which is the decimal is called the atomic mass. And the atomic mass is a calculation or an average of every single type of atom that exists for that element. And we call those varieties or types of atoms isotopes. And we'll kind of mention what that is, but we'll dig into those a little bit later as we go. So again, we have 2 numbers, and the 2 numbers, one is a whole number. That's how many protons. We can't have 0.99 of a proton. It has to be a whole thing. So I have protons as the whole number, and then I have the other, the decimal, atomic mass, or the average amount of stuff in every single possible one of those element atoms. So all that information is found within one of those tiny little squares. But the way that this whole periodic table is organized gives me even more detail about what's going on with those particles. So a couple key things on the organization of the periodic table is what row or column the element is in. Rows on the periodic table go this way, and they are called periods. And so the period that the element is tells us a lot of information. And as we go down the period on the periodic table, so as we move this way, what we're noticing is the number of protons is changing or increasing. Now, period gives me important information on how many energy levels there are on the atom. So if I'm looking at a particle right here, I know it's in row 2, therefore when I draw the model of the atom, it's got 2 of those energy level rings. So by knowing where it is on the periodic table, I'm getting more clues to information about one atom of that element. So we're going to work together to label that little periodic table on the side of your note. So check that out. First thing we want to do is just right above it, we want to write in the words row and period. So we kind of know what this is showing us here. Row and period. And we want to draw a nice big bold arrow in that periodic table, just showing that the row or the period of the periodic table goes this way across. We're not going to write anything in there, so you can just put it right across like I am. A nice big arrow. Okay, so we labeled it, and we drew our horizontal arrow on the mini periodic table, and now we want to label the different periods with numbers. And so these numbers are going to tell me what period number and therefore how many energy levels there are. And so each one of these right here is one period. So we're going to label this guy as period 1, 2, 3, 4, 5, 6, 7. And we won't talk too much about these down here, so we're not going to number those at this time. So for example, if I have an element right here that I'm looking at, well, I can trace over, see what period it's in. It's in period 4, so I know when I go to draw this element, when I'm thinking about what one atom looks like, around my nucleus I have 1, 2, 3, 4 energy levels. Okay? The other big thing that we're looking at here is the columns. We know columns run up and down, and so here we can see the giant arrow going up and down. And so each one of these is a section on the periodic table known as a group. So columns run up and down, and they are called groups. And the columns, the elements within those columns have similar chemical properties. So they all react the same when interacting with other elements. So they have similar chemical properties. Now, just like the period, the group number tells me something about the atom. The group number tells me how many electrons, so how many of those little negatives are rolling around in the element's outer shell or outer energy level. So again, gives me a clue to what that atom of the element looks like. So again, we want to look at our second mini periodic table diagram, and we want to label this one as columns, groups, and we can draw again inside. We're not going to write anything inside. So there's my arrow saying that the groups go up and down. And again, we're going to label the numbers here because each one of these is a column or a group. We want to record a number on top saying what value that group is. So here I'm going to start on the left. This is group 1, group 2. I'm just going to skip over this little section for right now. We'll come back to that maybe later, and you'll talk more about it in your upperclassmen chem classes. But then we've got 3, 4, 5, 6, 7, and this is group 8, and we put in parentheses 0, and we'll explain that as we get further. So columns and groups run up and down, and they tell me how many electrons are in that outermost shell or energy level of the atom. So here you can see a big periodic table with the element period and groups labeled. So across the top we have all the columns or the groups labeled, and along the side here we have all the periods labeled. And here's my little helpful hint to kind of remember the difference between these two. So periods run this direction, and I always think about like the period at the end of a sentence, right? And so sentences run this direction, horizontal. Oops. Sentences run this way. So I'm writing, and here's my period. So because the sentence is horizontal, I remember that periods are horizontal. That's my little clue that I use. Up and down then, these are our groups. So groups run up and down on the periodic table. So we label these up and down. And I always remember I'm hanging out with my group of friends, just chilling. I'm raising the roof. I'm lifting my arms up. That is why, or my little remember, to remember groups go up and down, periods side to side. The last little set of information we want to look at here are the major categories on the periodic table, and we have 4 of them. We've got metals, nonmetals, metalloid, and noble gas. And so these categories aren't telling me a ton about what the element looks like, but it's telling me about its properties. So if it's shiny or dull, who it likes to react with or bond with to make a molecule, different features about the element. So you have a blank periodic table with these categories outlined. I'm going to ask you just to do a mini color code. So first one I would maybe grab is nonmetals. Nonmetals is kind of this upside down triangle section. And really carefully, this guy over here. So go ahead and pick, whatever color it is that you want that to be, and just shade it in lightly so you can still kind of see those sections. And then in the key, go ahead and make a little note that that's your non-metal color. Same thing with metalloids. Metalloids is kind of that diagonal section there, so it's outlined already for you. It's kind of the in-between section here. So go ahead and color code that in-between section. Then we've got the noble gases. They're this far right column. There's just 6 of them. You want to make sure you pick a third color, mark it on your key, and shade those in. And then the metals, you could always leave white, plain, or if you wanted to color code them, you can, but it would be a good idea maybe just to write in the word metals here if it's going to be left white. So that's this whole section plus these down here at the bottom. And so we'll talk more about what characteristics each one of those groups have. But again, all the elements within that category have some similar properties. We have nonmetals and metals. Those tend to kind of be opposites. Metalloids are like an in-between. And then noble gases have their very own characteristics. So lots of info on the periodic table. We have our periods that run horizontal across the periodic table. We have the groups that run vertically, and then we have 4 major categories: metals, nonmetals, metalloids, and noble gas. Each one of those tells me something specific about the element that I don't get right from the periodic table square.